Okay, welcome. Today we're going to talk about compound inequalities. So please make sure you have your notes ready and make sure you're following along and filling in all the applicable information. So before we get into the compound inequalities, let's first talk about compound statement. So what is a compound statement? So in your notes, go ahead and fill this out. It's just a statement formed by combining two or more simple statements. Pause this video if you need to, but I'm going to go ahead and move on. So what do I mean by combining two or more simple statements? So what do I mean by that? Combining two or more simple statements. Well, let's take a look at this chart. Here we have an or compound statement. We're going to well, take a look at this chart. So here we have a few statements that we've labeled P, and a few statements that we've labeled Q. So when we're creating an or compound statement, we're combining two simple statements with the word or. And what does that mean? Well, if we use or, that means that our entire statement can be true when either one statement or both are true. They don't both need to be true, just one of them has to be true. So let's fill out this chart to see what I mean by that. So the first one says, for P it says 1 is an odd number. So is that true or false? Well, that's true. 1 is an odd number. 2 is an even number. Is that true or false? Well, that's true. P or Q. So P or Q, because we're using or, that means one of the statements or both have to be true in order for this compound statement to be true. Well, in this case, both statements are true, right? So because both statements are true, P or Q is going to be true. Now, the next one isn't going to be as evident because one of them is going to be false. Here we have 1 is an odd number, which is still true. 2 is an odd number, and that's false. So Q would be false. 2 is not an odd number. But P or Q would still be true because when we're using or, we just need to make sure that one of the statements is true. If one of the statements is true, then we are okay. Next one, 1 is an even number. That's false. 2 is an even number. That's true. This entire statement, this compound statement, P or Q, is going to be true. Why? Because at least one of my statements were true. Okay? So both of them don't have to be true in order for that compound or statement to be true. And the last one, 1 is an even number, which is false, and 2 is an odd number, which is false. In this case, P or Q, remember, we need at least one statement to be true. If we don't have one statement, then the compound or statement isn't going to be true. So in this case, this is going to be false because both of our statements are false. So P or Q is true when either P or Q is true. So they both don't have to be true. So P or Q is true when either P is true or Q is true or both are true. So here we have and. And is when both statements are true. So when we have a compound and statement, it's only going to be true when both statements are true. So let's take a look at our chart here. A dog is a mammal. Is a dog a mammal? Yes, that would be true. Red is a color. That's also true. So is P and Q true? Well, both statements are true, so yes, it is. Next one, a dog is a mammal. Still true. Red is not a color. That is false. So in this case, our compound statement is going to be false because with and, both statements have to be true. So next, a dog is a fish. That's false. And red is a color. That's true. But this would still be false because both of our statements have to be true. And last, we have two falses, so that would make this false as well because both of our statements have to be true. So one is P and Q true? Well, it is true when both P and Q are true. So this takes us to compound inequalities. So compound inequalities are going to have that and are going to have that or as compound statements. So a compound inequality is two inequalities or more that are joined with that and or that or. And we'll see how that translates with inequalities instead of just statements in a moment. So here we have an OR inequality. So remember, with compound statements, OR inequalities were true if either statement was true. So it's the same with compound inequalities. So this inequality is true if either this inequality here is true or if this inequality here is true. How would I graph that? Okay. Well, the first one says x is less than or equal to -2. So what we do is we graph it the same way we would if we didn't have that other part there. So it's less than or equal to, so we're going to have a closed circle, and then we'll be going to the left-hand side. And I should have done this in another color so you could see a little better. There we go. Okay, we're going to the left-hand side, this way right here. All right. Now, this is OR x is greater than 3. So we're going to have to actually plot another inequality on this number line. And because it's greater than 3, we're going to have an open circle, and we're going to be going to the right-hand side. Okay, so that means in this compound inequality, x could either be less than -2 or more than 3. Either way. How would you write this with interval notation? It's similar to what we did in class today. So here we have open parentheses, and we'd be going towards -infinity on the left-hand side. But we'd be stopping at -2, and we'd be including -2. So we'd go ahead and put that bracket. Then it's OR, and then our second inequality, which this time we'd have a parentheses because we're not including 3. And we're going towards infinity, parenthesis. That's how you would write that in interval notation. Here's another OR. So this time we're asked to solve, graph, and write the solution in interval notation. So first we'd solve it and just separate them. Separate them and solve them the same way we did in class today with our inequalities. So our first inequality here is that right there. So we would distribute, and that would give us negative 6x minus 3 is less than -15. Then we'd add 3 on both sides, which would give us negative 6x is less than a -12. And we'd divide by -6. So remember, when you are dividing by a negative, you have to flip that inequality symbol. So that would mean that x is going to be bigger than 2. And then we have OR 1 minus x is greater than or equal to 5. So what would we do there? We would just subtract by 1 first. That would leave us with negative x is greater than or equal to 4. We'd still need to get rid of that negative, so we could multiply both sides by -1 or divide both sides by -1, whatever you want to do, and that would take the negative away. We'd just be left with x. But again, because we divided both sides by -1, we would have to flip the inequality symbol, and that would give us x is less than or equal to -4. And then we plot it. So our first inequality here is x is greater than 2, and I'll do this one in green. So we're starting at 2, open circle, because we're not including 2, and we're going to the right, because x is going to be bigger than 2. And then the next one, x is less than or equal to -4. I'll do that in blue. And this time we're going to use a closed circle. We're including -4, and we're going to the left. Okay, how would we write this in interval notation? Well, if we look at our number line, we have open parenthesis, -infinity, and then we're stopping at -4, and we are including -4. Or then we have open parenthesis at 2, we're not including 2, and we're going towards positive infinity, close parenthesis. So let's move on to and. So again, think about the compound statements that we did a few minutes ago, but and is going to mean that both have to be true in order for the compound inequality to be true. So and inequalities, and I forgot to mention this before, if you didn't fill it out, or inequalities have a tendency to graph apart, and inequalities have a tendency to graph together. And that should make sense because remember, with and, both of them have to be true. So here we have x is greater than or equal to -6, and x is less than or equal to 1. So let's start with x is greater than or equal to negative 6. We're going to start on negative 6, closed circle. And we're going to go to the right, but we're not going to go all the way towards positive infinity. Because remember, both of these inequalities have to be true. Okay? So yes, if it was just x is greater than or equal to negative 6, we'd go all the way towards positive infinity. X could be any number from negative 6 to infinity. But if we look at our second inequality says x is less than or equal to 1. So I'm going to go ahead and put a closed circle on 1. And I'll do it in a different color. So this represents this inequality right here. So this inequality, x is less than or equal to 1. If we didn't have this other inequality, and if this wasn't a compound inequality, we would go from negative infinity all the way to 1. It would be 1 or lower. But because this is a compound and inequality, just like with compound and statements, both inequalities have to be true in order for the entire compound inequality to be true. So that means the only possible solutions would be where they overlap. Okay, because that would be the only area where both of these inequalities are true, and we need that with an and inequality. So that means the solution would be this section right here where they overlap. How would we write that in interval notation? Well, we're starting on negative 6. We're using a bracket because we can include negative 6, and we're stopping at 1. We're using a bracket because we can include 1. That's how that would look like in interval notation. So you could read this, and we'll talk more about this in class. I'm just going to go through it quickly, but because the solutions to an and inequality fall between two endpoints, they are frequently written in a more condensed form. So x, and I'm going to do this quickly. We'll talk about this more in class, but x is greater than or equal to negative 6, and x is less than or equal to 1 can be written in a different way. We could write it like this, negative 6. And if you read this reads the same way, because if you read it from right to left, right here, that does say x is greater than or equal to negative 6. And if you read this from left to right, that does say x is less than or equal to 1. And I know I've already taken up a lot of your time, so we're going to discuss this more in class. But this is another way that you could write and compound inequality. Let's solve one. So this is written in that condensed form that I showed you. If that confuses you, then just separate it. Separate it into two inequalities and solve. So if we read it from right to left, that says x minus 12 divided by 4 is greater than negative 6. So we just solve this, multiply by 4 on both sides, and this is number 8 on your notes, and then we would be left with x minus 12 is greater than negative 24. We'd add 12 on both sides, and we'd be left with x is greater than negative 12. So then we'd have to solve this one. X minus 12 over 4 is less than negative 2. So we would multiply both sides by 4, which would give us x minus 12 is less than, I forgot to put a 4 here, is less than negative 8. Then we'd add 12 on both sides, and that would give us x is less than positive 4. So our first inequality, x is greater than negative 12. We're going to have an open circle on negative 12, and we're going to be moving to the right. I'm not going to do it yet, but we're going to be moving to the right, and I'll put that in blue. That represents this inequality right here. But remember, this is an and inequality, so both inequalities have to be true in order for the entire compound inequality to be true. So our next one here, it says x is less than 4. Again, open circle 4. This time we're going to the left. So that means this inequality is only going to be true in the area that both of these overlap, that both of these inequalities overlap, which is between 12 and 4, not including 12 and 4, but between 12 and 4, which is this area right here. Okay? So how would that look like in interval notation? That would be open parenthesis on negative 12 because we're not including it, and an open parenthesis on 4 because we're not including it. So tomorrow we'll discuss more of these compound inequalities, focus more on solving some examples. But what I want you to do is I want you to go ahead and try to figure out up to 8. I want you to try to solve up to number 8, which we already did number 8 together, but I want you to try to solve and graph and plot all these inequalities all the way up to number 8. Make sure you also include the interval notation. I'll be looking for that when I check your notes. And tomorrow we'll do some more examples, and we'll focus on the rest of the time on numbers 9 and 10, how we could create a compound inequality given a number line. All right, I will see you tomorrow. Have a great day.